50% more, I don't know. There are lots of people who simply can't do that. So competitive running cost is actually an important feature of what makes a good heat pump. So what are the aspects of good heat pump performance, or aspects of performance that we can say make it good? Definitely the emitters. The bigger the emitters are, the more that it can provide warmth at a lower coefficient of performance, or a lower sort of level of output demand. The settings themselves are important. The U value of the home, so how much heat is lost by the home, and then the manner in which it's installed, and the sort of the system design, and so on. Now, what is unclear is how are these things weighted to, like, how much U value, and relative to the emitters, and relative to the setters, and relative to the installation. I will point out, and this will become clear as we go through, there are gaps in research which really do need attention. So just straight off the bat, there is no such thing as a trial where people have put heat pumps into EPC, D, E, F, or G properties to see what happens. How expensive are they run? How well do they keep you warm? What size emitters might you need there? And so there are these gaps and shortfalls, which I will refer to together. But these are the aspects, and they're all important. You can't say, or you can't deliver the good performance according to these measures if you don't address all of those, if all of those are not in place. So what's the scope of the problem that we're dealing with? According to the latest research, MCS Foundation, there's only about 200,000 heat pumps that have been installed across the UK, which is not enough. Absolutely, that's not great. And around 20 million or 20.25 million are on gas. The government's target, we all know this, this hallowed 600,000 heat pump installs per annum. There have been a little over 17,000 vouchers issued under the BUS scheme, which is the Wales and England boiler upgrade scheme, grant £7,500 to get a heat pump installed. At the rate of deployment of heat pumps that we've seen over the last 10 years, it would take more than 200 years to hit the government's target of 600,000 heat pump installations. So that's, I think, for lack of a better word, pretty tragic. So what's the problem then? The problem is we need to do this faster. So the question then is, how do we accelerate? How do we get this to happen faster? One way of looking at the question, or answering the question, is if we flip the question perhaps on its head. Rather than saying what's preventing adoption, why don't we look at what's enabling adoption? So what I did is I had a look at what we can know from the 17,156 BUS applicants that received vouchers. And there's actually some interesting dominant characteristics. So first of all, the average price of the installation of an air source heat pump was a little over £13,000. And that does not include any type of additional fabric upgrades. That is purely the installation, system design, and install. Unit, install, and system design. For a ground source heat pump, it was £26,917. The other thing we know is that the majority, and this is an interesting statistic, so 53% of all of those who have received vouchers were replacing a fuel other than gas. And that is despite the fact that somewhere between, so about 78% of homes, 78% of homes in the UK are on gas. So people are replacing things other than gas, that tells you something. And the other point is that the plurality, so it's not the straight majority, but as a category, it's definitely 41% came from the south of England. So what does this tell us? First of all, 13,371 as a cost for an air source heat pump, but you get £7,500. So that means to actually get the heat pump installed, you need a top up. The top up is basically double. So it's less than that, but let's say, so you need another £6,000. Maybe you're going to do some extra measures, but let's say we don't. So another £6,500 sitting in the bank account if you want an air source heat pump, otherwise you can't proceed. They're replacing something other than gas. Now that could very well be because what they're replacing is actually relatively expensive, or they're off grid. So therefore, these recipients don't have that dilemma where they're replacing a really cheap form of heating, which is natural gas, with something which potentially could be more expensive. Not to say that it is, but might be. And that's certainly something that's in people's minds. Or at least to get people off something very cheap is harder than getting something off that is more expensive. And this is sort of reflected in those figures. And the other thing is perhaps there's something to say about the climate in the south of England and the mentality of people or the perceptions surrounding the performance of heat pumps in that location versus other areas. Okay. So Nesta has recently undertaken or is in the process of a large research scheme to understand exactly what is enabling uptake in the bus scheme or preventing it. And their first statement is that for many households that want a low carbon heating system, they will need to upgrade their current heating system, that's radiators, emitters, pipework, as well as possible upgrades to the fabric of their homes, such as insulation. The current funding landscape separates these two aspects with different schemes and eligibility criteria and a complex and unapproachable subsidy landscape and a lack of funding to increase the efficiency of existing systems may be preventing some uptake of the current boiler upgrade scheme. And I think that finding from their, they do a person-centered, human-centered approach of interviews and analysis, that does sort of reflect this in the sense that it is expensive. There is a cost. There's 13,341. If you don't have that extra 6,000 lying around for these extra work, well, I guess you can't take it up. And it is, as we know, the subsidy landscape is relatively complex and how that will proceed. So from the research that I've undertaken using the systems thinking analysis, the main contributing factors, I think, first of all, it really is a material factor. So I have found time and time again, and I'll explain why this is, that the price of electricity, especially the electricity to gas price ratio, is the most important factor holding back the adoption of heat pumps. More important than fabric, more important than thermal efficiency, more important than anything. And you can understand this if you do a thought experiment. If electricity was affordable, green, and abundant, then it wouldn't matter so much what sort of fabric your home had, because you didn't need to conserve it so much. You could use more energy. And if electricity was totally green, then also you don't necessarily need the CO2 minimization leverage of the heat pump. But because at present, electricity is 4 times more expensive than gas, this creates all sorts of dilemmas, especially dilemmas in the social sector, in the local housing authority sector, but also many owner-occupiers who have concerns that going off of a very cheap source of fuel onto a more expensive source of fuel will place them at something of a disadvantage. Related to this is the physical condition of UK existing housing stock. Now, I know this is well known to everybody, and I'm not trying to belabor the point, but the housing stock in the United Kingdom is the oldest and the leakiest in Europe. It leaks heat 3 times faster than Germany, and most houses are EPC band D or below. Now, again, improvements have been made to install, improvements have been made to understanding of setup, emitter size, and heat pumps so that heat pumps can function perfectly well and not even be so cost prohibitive in a greater range of properties. But this is still definitely relevant. And this is, why the emphasis on fabric has consistently been made. And I'll also point out that this appears time and time again in the research, that the lower the thermal efficiency of a property, the less effective a heat pump's performance will be. The other thing to say is, even if we suggest that all of the deficiencies of the thermal properties of a home, so even if it's really leaky or drafty, can be overcome with suitable emitters. So in other words, if you just put underfloor heating everywhere and really large radiators and given enough time to get everything up to temperature, it still provides adequate warmth at a good coefficient of performance. Doing all those changes to the emitters, that's not free. That has a cost too. So there's a material cost, whether you're doing additional fabric upgrades to make the box more insulated so that there's less heat loss, or you just go and make the emitters massive so that they can express more heat all over the place. There's still a cost. Those, underfloor heating isn't without cost, and some homes may or may not be able to accommodate that anyway. So these are important considerations. And then, of course, you've got the unit and installation cost, as we saw before, a little over £13,000. Now, part of my recent research was to understand what is the running cost of an air source heat pump versus a gas boiler. So if we're trying to displace the dominant form of heating in the United Kingdom, then what are the consequences of doing so for the average home, or what evidence is there out there? And so across time, and we're going back a long way here at the far end, the left-hand side, I mean, that's going all the way back to 1986. But what you can see, the trend is that heat pumps have become more efficient, or let's say they've been performing better. So higher levels of performance over time, even though the price of electricity relative to gas has become less favorable. So what we do know is the technology has been improving, that's for sure. The install processes have been improving, that's for sure. The setup's been improving, that's for sure. And then the understanding about emitters in particular has also been improving. So heat pumps are getting better and better over time, and but they're still really fighting against a totally unfair relationship between the cost of electricity and gas. So in recent times, there are quite a number of heat pumps that are in evidence with large-scale demonstrator projects and studies that show that nice, tidy, well retrofit property, might only cost you say 4 or 5% more than an equivalent efficient gas boiler in the same home with the same level of insulation, and that's obviously fantastic. The summary findings of the research, I've already said that about electricity. In a home that is, let's say, at the higher end of thermal efficiency, so we know it's well insulated, we know that it's extremely draft proof. And this is not necessarily saying we have the biggest and most perfect emitters. This is like we'd say an average emitter scenario and a regular 7 or 5 kilowatt heat pump, depending on the size of the home. In the ideal situations, it's only 9% more expensive to run than an efficient gas boiler. And I think generally 9% more expensive to run, that's something that most people should be prepared to pay for the cost of a carbon-free lifestyle. And indeed, people who find themselves in properties that are of this type would generally find themselves in a higher income level. That's the evidence suggests that people who live in EPC B and A homes or passive house homes are usually can be means tested into a higher bracket, and therefore 9% more expensive to run. I mean, you can almost write that off. In unexceptional circumstances, and I explain in my report how I've sort of determined this, these are homes where they were either not on a specific form of electricity cap rebate that sort of brought the price of electricity down, let's say in an unusual way relative to the ordinary wholesale and retail electricity to gas price ratio, or they didn't have, so the unexceptional circumstances are not on a price cap, don't have PV, because some of the studies did have PV, which you then have to take into account. And they are not homes that have a really high level of insulation. So these studies, the unexceptional circumstances, were ones that, and I estimated this, it's kind of like a home around EPCC. It's not a perfect estimation, but it's sort of at that level. And in EPCC homes, the evidence that was obtainable from these studies that are out there of large-scale trials and demonstrators is that it's about 36% more expensive to run than an efficient gas boiler. To put that in context, for an average 2-bedroom, 2-person home, that would be about £550 extra per year. So again, I think just bearing in mind that it's an uneven society, maybe for someone like me and others on the call, $550 per year, that's also doable and a fair cost for a carbon-free lifestyle, okay? But I'm sure there are other categories of people where £550 per annum extra that's too much. So that is not tolerable. So something would need to be considered there from a policy point of view. And then the final thing to say is that the addition of photovoltaics and battery storage makes a considerable difference and is absolutely a great thing to do if you can afford it. I mean, solar arrays and their storage systems, they're not cheap, they're not free, but if you can't afford to do that, it ends up say ends up taking about 10% off that relative cost between gas and electricity. So for example, where it was around 36% in an EPCC, more expensive than an efficient gas boiler, if you have your PV and your storage, then now it's only 25%. So it rebates you like 10% off that differential. And these are estimates. I mean, and if you read the report, you can see how these have been arrived at. Now, I will point out an interesting case study. There's a wonderful academic and researcher who works at Durham University called Tom Bray. And he has a YouTube channel, which you can just go check him out on YouTube. He's really, really informative, a fantastic presenter, really lovely person. And he's doing this whole series on my carbon-free lifestyle. He's put a 5 kilowatt ASHP into a Victorian terrace. He told me yesterday that it was EPCC. So this is in this median level. This is not BOA, it's not a passive house. It has good insulation, double glazing. In January, he got a coefficient of performance of 3.23 out of it. And when he did the calculations, it was only 5.5% more than a gas boiler. And then if you were on, then doing a tariff comparison, it's like 14.8. So this is also important to know. There are examples of homes which would receive an EPCC rating where a heat pump, again, with the right type of emitters, you can then get to a level of that it's not so unfavorable relative to the gas boiler. And that's the case, obviously, as you can see with Tom Bray. By the way, anyone who wants these slides afterwards, please email Glenn, and then we'll email it to you, because all the links and everything down below, so you can go and have a look for yourself at the evidence that I'm using to make these claims. Thermal efficiency, these are just estimates. So what is the coefficient of performance you can expect from a heat pump at various EPC ratings? Now, the data for EPC A, EPC B, and EPC C are within the studies that are used within the report that I've prepared and that I've read, because they will say that. For example, they'll say, these homes were EPCC, then we upgraded them, or some of them would have upgraded them. So now they would be the equivalent, based on the SAP calculations of B or A or whatever. And here's the outcome, and here's the performance we get from them. It gets much more difficult to estimate when you start to get into E, B, C, D, E, F, and G, principally because nobody puts heat pumps in to measure and trial them in those types of homes, because it has forever been the presumption that the heat pump will perform terribly. So why would you want to demonstrate that? But it's important research, and we need to know, really what happens. I will say, again, one of the issues, just in terms of this sort of logic about the relationship between the efficiency of a heat pump and the thermal performance or efficiency of a home, is that the academic literature, the research that certainly I rely on, principally, I'm going to look at a study that's in, say, energy policy or any of the engineering, journals and so on. They still maintain, as you can see here, and this is from a 2023 journal article, energy efficiency is cost-effective and a prerequisite for heat pumps to operate efficiently in most housing types. So this is just to be aware of, that it is still very much in the, in the literature and in that sort of, in that domain. So what are we talking about cost then? Because we need to understand what the cost is, what's the problem, how do we accelerate it, what sort of policy prescriptions would we need to make for interventions to facilitate this. According to so the UK government figures, based on, as I said, the Ofgem and DESNZ review of the bus applicants, is we've got 13,341 for the unit heating system and installation. On your EPC guidance, and I just took one at random from EPC C 2-bedroom, what did they suggest was going to cost you to get it to be in the recommendations? These are the costings they put on there: 3,300 for double glazing, £80 for draft proofing. Now, we can disagree about whether that's accurate, but that's what was in the government's EPC guidance. So that brings you to a total, so say they get an EPCC to a B level, which we know that the heat pumps will work well in. So you get their heat pump ready, just put them in. So that's 16,721. Palmer and Terry did a large trial of heat pumps in numerous houses of all different types. And they suggested there's quite a broad range with the cost of putting the heat pump in. So it was between a little over 10,500, let's say, to almost 20,000. But they stated that their fabric improvement cost was an average of 2,820. So if we add that to the averages, you have this sort of broad range here. Then Energy System Catapult, with their large 800 heat pump trial study, suggest they provide a range of what it costs to put the heat pumps in. They don't specifically express what the fabric improvement is, but they say that the average cost for the install system and fabric was 14,800. I will point out with the Energy System Catapult report, which came out in February of 2023, it is a very well-known and well-cited report. It is the report from which the statement that heat pumps can go in any home comes from. I just want to put a little asterisk on that and say that anybody who really, really hangs their hat on that report needs to read the engineer's report that underwrites that trial, because they are very clear to say that of the 800 houses that came in the trial were very carefully selected out of around 8,000 applicants, so that the 800 were only homes that didn't require a large amount of intervention. And they disclose that in the engineer's report. Subsequent to that, they then have to say, consequently, because we curated and just selected the most energy efficient homes, the findings of this report should not be implied or are not applicable to the wider UK housing market. So that's just an interesting tension within and surrounding that report. So the Energy System Catapult says heat pumps go in every home. That's true. We've already said they can heat every home. But the engineers themselves selected a very particular type of home and then said that the findings, in other words, the performance figures and the costings and so on that emanate from the report, should not be considered applicable to the wider UK housing market because of the curation that they did with the selection of the housing sample. So continuing with some of the more contributing factors here. So certainly there are, I want to go into psychological factors. So because people are worried how much it will cost when you install a heat pump, there is a concern that perhaps we need, from, as I said, housing associations and local housing authorities, that it needs to be fabric first. So that itself is a barrier. So what we really need to do is bring people to the table in a collaborative way, meeting each other in the middle and in an, I think, an honest and transparent way, and say, this is what it would cost. This is what interventions are required, rather than kind of being in our own silos where we just want to say, okay, the heat pumps can work anywhere, they're great, no worries. And we're not going to talk about perhaps the actual costs that are involved in getting them to work favorably as a good performing heat pump. And then similarly, the fabric people only want to talk about the downsides of heat pumps. So I think there needs to be more transparency about that. And this relates then to the performance anxiety. There is a worry certainly from owner occupiers that they won't get sufficient heat. There is some justification to that, but there's also many examples where that's not at all the case. We have seen that there's an alternative technology stasis, especially with respect to local authorities. There was a lot of lobbying by gas networks and gas operators that hydrogen was going to be the solution. Subsequently, we found that that's a really unrealistic proposition, because most of the hydrogen, being so expensive and complicated to get together, is probably going to go to industry, and there won't be any at any reasonable price for domestic. So that is not a solution. But this has been something that has caused some decision makers to defer the decision to put in heat pumps. And then there's the split incentive concern with the PRS and so on. Now, from a regulatory point of view, probably the biggest thing is that there aren't mandates. So that's the biggest regulatory barrier. It's like the absence of regulations is a massive regulatory barrier. So until recently, there was no expectation about new homes, and we presently don't have mandates on homes that should be able to be mandated, which are A and B. And of course, planning laws are complex and complicated and arduous, and Nesta has recently done a fantastic report in respect to that to just show how messy it is to go through that process. And then from a policy point of view, we do have issues from lobbying from the industry sector. Industry and sector lobbying from gas suppliers and boiler manufacturers. We saw this recent argy-bargy where the boiler tax was kicked down the road because of the sense that this was going to cause market interference. And I think there was a little bit of game playing there from the boiler manufacturers to give that exact impression. But that was enough pressure and enough lobbying to have a policy impact. And then, of course, we do have this issue of path dependency, meaning that the UK has the most efficient, the most effective, the greatest penetration, the best gas network, and historically has been that way. And it's super cheap and works really well. And that makes this transition difficult. So there are some ancillary factors which are just worth mentioning. And I'm not going to mention all these because I'm conscious we're running out of time and I do want to get to some other things at the end. But for example, some things are proximate factors of barriers and other things are ancillary. So for example, grid capacity, I view that as an ancillary factor, meaning that I don't know how many people chose not to install a heat pump because they were worried about grid capacity. It's true that grid capacity is a problem, and it's definitely something that needs to be thought of moving forward by, policymakers and planners and so on. But I don't think that that's what's stopping people installing heat pumps now. And even when I spoke to developers about that, they would be really the only category where that might be a legitimate argument, because the obligation is on them to do the infrastructure requirements from the DNO for the grid if they're going to do a site and so on. But there's still a market mechanism for them to recoup those costs. So I think it's, in the case of the developers, it was more the case that there was no obligation. So, and indeed, the fact that now in the new home standard, it is going to be an obligation for them to have clean heat. So they are going to need to do, infrastructure, grid improvements. We'll see actually that this is a market driven because of the obligation and the mandate. Well, now in some ways that issue will get attended to, or is attended to, as you get through scale of market. And then I think the other thing to talk about before I move on is the consumer and installer awareness and perception and the installer numbers. So the installer number is a bit of a tricky one, because it's hard to know whether it's a supply or demand problem. So chicken and egg. So is the problem we don't have supplies because the demand isn't high enough to create a cascading sort of feature within the market for installers? Or is the problem that because we don't have enough installers, we can't boost the boost the demand for heat pumps? It's difficult, and I don't want to say I know for sure which one it is. I wrote about in the 2023 report about both sides and the arguments in favor and the evidence to support each case. I think, though, in general, this is precisely something that systems thinking deals with, because that is a market failure of some kind. We don't know if it's a supply or demand issue, but a policy intervention to correct that market failure will be necessary. So the government gets in there, drives demand, and then they can also do a training side for supply, and then the market can start to regulate itself. Reach an equilibrium, I guess is what I mean. And then the other thing, I suppose, with respect to, installer perception, I have heard recently there's anecdotal evidence that installers don't really know just how much more you can improve the performance and the thermal capacity of a heat pump through emitter size and through relatively easy things. So there are stories of installers not wanting to install heat pumps in certain types of properties, in certain types of there was a case study last night put on by Loco Homes, which was for a terrace in Glasgow. And the testimony was that the installer didn't want to install it. So they said, no, it's not going to work in your home. That turned out to be incorrect. So again, this is a piece of the puzzle that needs to be addressed in a collaborative fashion so that people can understand, case studies are useful, but also we don't just want to cherry pick the best case studies, only the good case studies. There needs to be also evidence from sort of unsuccessful examples, so that then the limits of that claim can be understood. Okay, so going now to the policy recommendations. Based on everything, the bus grant or bus equivalent should be increased to £15,000 to meet what we've said about the install in those areas, because 7.5 is just not cutting it. And it really means that the people who are taking it up are probably people who don't really need the money because they already have money set aside. So they're not really the best recipients for government funding, I would have thought. And I do believe that all of this should be means tested. So we need to create at least a minimum of 3 categories: can pay, can contribute, or fully funded. And how you want to work that out is, that's something for, economists and people, more wise on these things than myself. You could use tax brackets, but whatever. But there needs to be a group of people, so for example, my brother and sister-in-law make a lot more money than me. I'll put them in that can pay. I'm in the can contribute. And then, there's people in my apartment building who would be fully funded. So I think we can know vaguely that there are people who are going to need, that 15,000, all of it. Other people are going to pay half themselves. And then there are people who really will just pay for it all. I think we know enough now about the performance of heat pumps and the way they can be improved with setup and emitters and so on, to say that we can just put a mandate on EPC A and B homes. It's not a huge number, but it'll be like an extra 10,000. And I think we can do this almost immediately. Now, I guess you could look into how important is it to means test it. I think it should be means tested in general, but the the evidence suggests that people who live in EPC A and B homes typically are of a socioeconomic situation that they can probably, or an economic material situation, I should say, that they can, bear the burden of this sort of process. And then the same thing about prohibiting installs. And then continuing with a mandate for clean heat on EPC C for 2028. I think we can start bringing these mandates in closer. I think we are seeing much more evidence that heat pumps can provide adequate heat at a reasonable cost, within that EPCC range. And I think, the drawing that line in the sand and making it a mandate, I think is going to be very useful. Obviously, the local planning rules need to be updated and so on. And I've talked about, we need to get all other homes that we can, for which there is a business case, up to EPC so that they can then go through that process as discussed. I think 2030 is reasonable for that. And then finally, although this is probably least useful for all the people on the call here, if we could just reform the electricity markets, and I know DESNZ has gone through some process in that they are looking at that, and that is in the works. But if we could bring that electricity to gas price ratio down to 2.5 to 1 or 3 to 1, then suddenly maybe it means that you can put heat pumps. The heat pump ready properties now go all the way to EPC-D. So I think I'll wind up my my presentation at this point, stop sharing, and then I know I gobbled up a lot of time, and for that I apologize, but thank you very much for your attention.
Thank you very much for that, Nicholas. Really, really interesting. A couple of questions submitted so far, a couple of anonymous questions. Just remember the Q&A box is at the bottom of the screen, so if you do want to submit your question, please feel free. So just a question here asking, what do you see as the most important areas for future research to advance the UK's decarbonisation agenda?
Okay, so I think just the one thing, and I'll be quick on that. So I think the most important thing is we need to do a trial in the lower performing properties. So I'd love to see a large scale trial where we put heat pumps into houses that are EPC D, E, F, and G. We offer those occupants a guaranteed price cap so that heating is not going to increase from what it was previously. And then we're able to say that. And then I think we also need to figure out like a way of really understanding what is the best measure, because the EPC is a totally imperfect way of measuring this anyway, because within an EPC band, you could have a super well thermally insulated property and one that's less so. And part of the EPC calculation is what type of heating system you have. So for example, you could have a very efficient home, thermally efficient, but it has electric heating. And then that same home with gas heating is a much higher EPC rating. So anyway, so it's an imperfect measure. So two things. One, we need to install into properties which are, like harder to treat, like not well-performing properties. And then also through that, understand what is the best measure. Is it airtightness? Is it U value? Work out what that measure is so that we can then diagnose what's required with what properties.
Great, thanks, Nicholas. Another question here just asking, as per the BUS figures, the mean cost of installing an air source heat pump was 13.3 thousand in an existing home. Are you aware of any evidence or data of what this cost may be in a new build and whether it will be much lower?
So I've spoken to developers that put heat pumps into their new homes, and they discussed, the reality that new homes that were built in the last, 5 years are going to need to be retrofit or, to have some changes. And the general view is it's probably not going to be much cheaper because there's an issue with pipe work insofar as you need a larger diameter, generally speaking, pipe work for because of the lower flow temperatures for heat pumps. So you're still replacing the pipe work, still replacing the emitters, the controls, the unit. There's still design and installation. I'd say it probably is cheaper, but it's not going to be a heck of a lot cheaper. It'll still be within that realm because a lot of the same things are going to be done. So maybe the argument could be that it's because it's newer, it's sort of easier to make those modifications than in an older home. That tends to be the case just in any type of renovation. But I wouldn't expect it to be a hell of a lot cheaper.
Thanks, Nicholas. We'll just try and get through as many of these as we can. Another anonymous question here, just asking, what is the state of the evidence base on the regional variation of heat pump running costs? Could lack of this cost certainty be a barrier to voluntary adoption outside the south of England?
Yeah, I think that's definitely something that I was sort of intimating there. The climate's different, so people feel as though, there is a view that heat pumps perform better in more temperate climates. So, for example, most people, I think, would assume that the heat pump is going to be cheaper to run in London than it will be in Glasgow. But again, there are many things that can be done to offset that differential in a given house: larger emitters, flow temperature modifications, setup, timings, and so on. But I do think that because people don't understand that yet, that is definitely part of what's influencing that decision-making process. I would imagine that people in the south of England would just, as an aggregate rule, feel more comfortable, and that is, you're seeing that in the distribution, the regional distribution of the applications for the bus grant.
Thank you very much. A question on grid capacity. From speaking to developers, how big of a concern is grid capacity according to them?
So I think it isn't. It's kind of like, it's not the principal barrier. The principal barrier is that there was not, up until recently, any mandate. Speaking to them about Part L of the New Home Standard 2025, they're okay with it. They're moving ahead. They're going to do it. It just means that the site will be, that will be factored into the economic and business case for each site, their interactions with the DNO. But that, I don't believe that, now that they have that obligation through Part L in the NHS, that that's going to be a barrier. It just means that it will, maybe there'll be a marginal increased, cost passed through to the consumer, on sites, depending on the scale and the size and what they have to do. But I don't see it as being a barrier. It was more a frustration that they were raising in advance, but they didn't say that that's stopping them from doing it. Because it's a business calculation in general. If there's enough viability, and we know that one thing the UK doesn't have is enough houses. So I think, probably the biggest frustration from the developers was that they find, that generally policy tends to stand in the way of letting them build. I think that's probably more of a barrier in general, but that's a different thing.
Great. Question from Paul Williams. If you could change only one thing to increase the uptake of heat pumps being installed in retrofits, what would it be? Would that be funding, education, etc.?
That's a great question. It would be funding. It would be funding. And I think that means tested funding portion that I said, I think that if the bus was increased now to the level where it covered for people who were EPCC and above, like I said, somewhere between 15,000, 16,000, I think you would see enormous uptake. So in other words, every single person who wants to go on this journey, who wants to have a carbon-free lifestyle, but doesn't have to take out a loan for it or borrow money from their family for it, because I don't know how many people have, a lazy £6,000 to £10,000 sitting around. I know I don't. So I would have to make things work to get that to happen. So I think it would be funding. And I think then what will happen is the funding will dramatically increase the market, and that'll have cascade effects. And then they'll be able to speak to people down the road. Oh, I did it. It's perfectly fine. It's great. Oh, I didn't have to do as much as I thought I would do, et cetera, et cetera. This is where the government intervention is required to disrupt the market failure aspect and really kick things on. I think so many of those ancillary factors, the grid, the installers, the consumer perception, blah, 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 would be radically changed with increased funding, the right amount of funding to get heat pumps in people's homes. And then I think a lot of the other stuff would take care of itself, and it would start to sort of build momentum and a sort of a critical mass, hit terminal velocity of deployments to a point where people are talking about, in just casual parlance, about how good their heat pump is working. And I've spoken to a couple of people before. It works the other way as well. You go into someone's house, you see that they have gas heating and a gas, stove, and you're a little bit like, oh, really? Why are you doing that? Like, why don't you have a heat pump? And then they're like, what do you mean? And then you can tell them the story about how you did and how great it is. And that would be a feature of the reality of us moving, in the same way that we've seen that happen with electric vehicles. You could start to see that happening with, electric heating.
Thanks, Nicholas. I'm conscious we've only got about 3 minutes left, but we hopefully might be able to cover 2 more questions. So one here from John Price, just asking, what are the similarities of heat pumps to heat networks?
So because most heat networks will need to use big heat pumps, they're generally the same principle. All the same principles apply, except there's an argument to say that there is a slight thermal efficiency because it's not multiple units, it's like one larger unit. But there are other issues. The planning takes a long time. Putting the energy centers in takes a long time. So whereas, you can fix a home with a heat pump in, 4 weeks, you're done. Heat networks takes a long time. It's a large investment, millions of pounds, 3 to 5 years. So I think so my view on the heat networks is that some parts of the nations are going to need to have heat networks. And that's just an absolute, because of the physical reality of the properties. Either they're heritage listed and they can't have heat pumps, or the other thing to say at this point, I'm sure it will come down the pike. There will be technological development. We will have indoor air source heat pumps, fully indoor. That will happen. But until we have that, there are lots of properties that are going to need to have heat networks. So the difference, it's the same principle on all of the thermodynamic principles, the same principle of what makes a good heat network, like a good heat pump. It's no different. All those things are still the same, especially because heat networks will just use usually a massive heat pump to do their work in the future.
Thank you very much, Nicholas. I'm conscious we're just about to run out of time, so there are a few questions that have been submitted we haven't got around to. But what we're going to do is send out a short roundup email to all attendees, and that will include the presentation slides. There'll also be links to both of Nicholas's reports, which are featured on the Cache website. And what we'll do as well is, Nicholas, if that's okay with you, perhaps you could just draft a few short answers as well, which we can include in the email, just so we've covered everything. But just a big thank you to everyone for coming along today. I hope you found that useful. If you've got any more questions, please feel free to email myself. I will drop my email and the follow-up email as well. But yeah, thank you again to everyone, and hope you have a good rest of the day. Thank you.
Thanks very much. Thank you. And if anyone wants the slides, we can send them out as well.